Hello, I am the Bookworm, and welcome back to another solving video. Today I will be solving Outrageous Fortune by Timotab. If you would like to try the puzzle yourself, there will be a link in the description under the video. So, the rules of this puzzle. We have normal Sudoku rules apply, so that's place the digits 1 to 9, once each in every row, in every column, and in every 3x3 box. Then we have slingshots. So these, small purple arrows. If small purple arrow is present in a cell, the digit in the cell the arrow comes from appears in the grid in the direction of the arrow at a distance of n cells, where n is the digit in the cell arrow, in the arrow cell. We have examples, so let's show this off. E.g., if row 4 column 3 is a 5, that's here, and if row 5 column 2 is a 2, then row 7 column 2 is also a 5. So this cell appears 2 cells in the direction of the arrow, because the arrow is pointing down this way, and the digit in the arrow is a 2, so you have to go 2 cells from the arrow, and then this digit goes there. So that's how slingshots work. Then we also have these arrows, and digits along an arrow sum to the digit in the circle. So that is all the rules of the puzzle. And now let's reset the timer, and let's begin solving. So, to begin, this sums to at least 6, so we can pencil mark that. And this one sums to at least 6 plus 1, so that's 7, 8, and 9. Actually, just this row, because that is a lot of digits on arrows in one row. Because these sum to at least the minimum of 1, 2, 3, 4, 5, so they sum to at least 15. And if we add on that one, then these cells all sum to at least a total of at least 16. And that's equal to sum of these two cells. So these two cells sum to at least 16. So if they're 16, they're 7, 9, or they could be 17, which is 8, 9. So we only have 1 degree of freedom, which means this has to be a 1 or a 2. And yeah, that gives us the 7, 8, 9 triple here. So we said there's only 1 degree of freedom. So either this is a 6, and this is a 1, 2, 3, 4, 5, and that's a 1. Or this is a 5. Well, actually, if this is a 6, we have 15 here, and this can be either a 1 or a 2. Or this is a 5, which gives us 1, 2, 4, 6 here, so these sum to 16, and that would have to be 1. But this appears 5 or 6 cells. That's 1, 2, 3, 4, 5, 6. Okay. Okay, and both of those are currently valid. Interesting. This cell's not green. That's fine. Right, I guess we can pencil mark this as being at most 4, because you can't shoot a digit off the edge of the grid. And it can't be 1, because that would mean those two digits are the same, which fakes because they're in the same box. Oh, this is being pointed by this arrow. That is kind of interesting. This, again, it's 1, 2, 3, 4, 5, because it's can't go off the edge of the grid, but it can't be 1 or 2, because I put this digit in one of these two cells, and then it repeats in the box. So it's 3, 4, 5. That puts this digit in one of these 3. It's not those, because 2, 3, 4, that's 5, 6, so it can't be the same, which means that's not 4. If it's these two are the same, that's interesting. So it means they both have to be 2, and it means this is 3. Oh, I think I see it. So if this is 5, that's a 6. If this is a 2, if this is 5, that's a 6. If this is a 3, that has to be a 2, because it means these have to be the same. That's a 2. And then this has to be a 6, because otherwise the math doesn't work. If this is a 5, this has to be a 1 in order for to not have the total be too high. Which means this is always a 6. Okay, so now we know where green goes over here, because This cell is green, it's just potentially yellow as well. It's not, it gets slightly confusing coloring, but yeah, one of those is yellow, this cell is green. Okay. And green is going, yeah, if we can prove this is yellow, it would be quite interesting because then this is going to be 1, 2, or 3. Because it would put it in the same box. Only this being all of 2, 3, 4 doesn't really matter because you don't know anything about this digit. Not a lot of clues here actually. We have quite a lot of clues down here, but we don't know anything about them yet, which is quite interesting. This clue, yeah, this one maybe, because it's again 1, 2, 3, 4, 5, and it can't be 1 or 2 because that would repeat a digit in the box. So it's 3, 4, 5, and it puts this digit in one of these. It can't be that one because this digit we know goes there. So it appears in one of those two, which does make this 3 or 5. Okay, okay. Yes, compared to like some of these other ones, this is 2, 3, or 4, because it can't be a 1, because put that there and there, so it's 2, 3, or 4. This one, again, can't be 1. I don't think most of these can be, no, that one can be 1, because those two can be the same. And same for this one. Yeah, the diagonal one is interesting because it's got a lot more options. Also, this cell can appear multiple times in this row, in this diagonal, which you can't do for the horizontal and vertical ones. So that's kind of interesting. So even if we like place this digit in the diagonal, we don't actually know what that cell is. I was thinking more about this, yeah, probably, because interactions between this and this. What's the biggest digit you can have on here? If this is 9, you can have 1, and then this one's to 8, in which case 1, 2, and 5 for 1 there. Really? No, that doesn't work. But yeah, because if this right, if this is 3, that's a 2. And then what are these cells? They're minimum of 1, 4, and 5, which makes this arrow way too big. So that case doesn't work. It has to be 5, and that is not yellow. Yellow goes here. Okay. Still don't know what yellow is though. I'll pencil mark that as 2, 3, or 4. This, I guess, is 1, 2, or 3. We did know that right from the start, just from this arrow. Because this one's at least 6, so that's at most 3. If it is 3, then this has to be a 1, 2, 3 triple, and that's a 4. Which I guess is fine. So this is kind of interesting either way it ends up, because putting the same arrow gives us information about this, or gives us information about this arrow here. This slingshot. Because if this is red, I don't know if it tells us anything with red. It just tells us where green is in this column, which is between 1 and 6. Oh, I guess that's interesting. It's not 7, 8, and 9. And that's also not 7, 8, 9, which means the other 7, 8, 9s in this box go up here. Guess that's something. Can we do 7, 8, 9s in this box? Because we've got 4 spots. Can we eliminate them from one of them? Don't think so. Oh, this can't be that small, can it? We have two fairly low digits here that are taken out from the arrow. Ooh, ooh, 789. 789 in this column. Because this arrow has a maximum of 4. I guess it can. Oh wait, yeah, that's worth benchmarking. And the biggest digit in this can be is 4, because you can't have 5, and if it's 6, it's already minimum sum of 9 here, which is going to be too big when you add on that cell. These are now 1, 2, 3, 4, which gives us a 1, 2, 3, 4 quad. So I guess we can benchmark this in as a 6, 7, 8, 9 quad. So that not being 6. But we can do better, because 7, 8, 9s in the column, we only have 1, so we need 2, 7, 8, 9s in here. You can't have 2, 7, 8, 9, 1 here, that's going to be something way too much. You need 1, 7, 8, 9 here, and 1 on the arrow. So this is bigger than 7, 8, 9, or bigger than 7, because it's the sum of a 7, 8, 9 plus something. And it's a 7, 8, 9 plus the other 1, 2, 3, 4 that's not up here, which is at most a 2. So both 3 and 4 are up here. Right? Yeah, there's neither 1 and 2, 1 or a 2 on it, because that's a 7, 8, or 9. And even if you take the lowest of those 7, the most you can add to it to get to a single digit number is 2. So 3 and 4 can't go here, so the only place they can go are here. Those are 3 and 4. You can take 2 out of there. That is a 3-4 pair, so we can take 3 and 4 out of here. Okay, this is, depending on the 3 or 4, is indexing into one of these two cells, which is probably not that helpful. 8, 9 tells us, yeah, one of these two is 7, because that's not 7. So that's not a 7. Oh yeah, one of these two is 9. We got that from the maths at the start because it's on either 16 or 17. So either 7, 9 or 8, 9. So you can move 9 from here. Oh, right, we can move 9 from there. That's not 3, and that's not been for a while. Oh, so that sums to 3. This sums to 3. If it's a 7, this has to sum to 4, and it's a 1 and a 3. If it's 8, these two sum to 5, and they can be either way. Also, this is green. That's not green. This is green. Just because they have to be the same one too. So these two cells are the same. There's a lot going on here. A lot of deductions coming in. We're left in this box. We have it's either it's 3, 4, 5. 5 and this 3, 4. So but this is pointing where green goes, which can't be 3 because that'll be here. That's obviously not a green. So green goes in one of these two cells. We can't see if it's here because then we have another arrow indexing where green goes. I know we only have 1. Okay. With 4 and green goes here and we have another arrow indexing green. Or 5 and green goes here and this cell appears in one of these two. But also this is either 4, 5 or 1, 2, depending on whether this is a 3 or... Okay, it's never 5 because if... No. Yeah, if this is 3, then this is 4 or 5. If this is 5, then this is 1 or 2. Okay. 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 Also, I'm going to swap out green for blue, just because I want to be able to mark. The green now doesn't mean the same. It's meaning I'm using it to mean slingshots that we've completed, so we know there's no more information coming from them. Just so I know not to look at them anymore. This is completed because we know these two are same. There's 6 apart. Same for the 5. We've got all the information we can get from it, so we don't need any more. I feel like it might be worth colouring the other one too, because we know, well, we know it goes here, here, and then on the arrow. But then that kind of gets awkward with the red colouring, unless you remove the red colouring. But I'm not sure if I want to. Okay, because this cell sees a 1-2 pair, and it's at most 1, 2, 3, 4, 5. So you can now limit that to 3, 4, 5, if that means anything. It's down here. These cells all have a lot of options. Yeah, like these clues down here are just, there's like no information about them. These almost nothing. Like this whole bottom left corner is very unclued, is very low clued, which is pretty impressive. Okay. Yeah, we said this, it depends on whether these sum to 4 or 5. Oh, oh, there's some interaction between this. Because if this is a 2, then these are 9, 8, and that's 7, and that's 2, which works. Okay. If this is a 1, then that's an, if there's a 1, then this this whole lot sums to 16. That's 9, 7. That's 8. Yeah, in that case, these are ones. These are both ones. If this is a 7, these are 2s. If this is 8, these are 1s. If this is 8, these are 1s, and these sum to 5. Yeah. If this is a 7, these sum to 4, and it's a 1, 3. If it's 8, these are 2s. This is a 1, and that's a 3. So like there's probably some slightly different ways of doing the maths here. Like get to that directly without considering both cases, like working out the difference sum between these. Because wait, yeah, there's some way of doing the maths that gets you that directly, I think. But the case checking works as well. This is a 3, and we still don't know this, which is kind of interesting. But we do now know that this digit goes 1, 2, 3, 4, goes there. These are now 4s, which takes 4 out of those halves and makes that a 5. That's a 3, which sees this digit. That's now a 3, that's a 5. I guess we know that's red, except that also means the red is no longer useful. The red was never helpful. Okay, and I'm greening that because that slingshot is now used. The 5 now puts this 1, 2, 3, 4, 5 down here. Okay, that's a 1 or 2. That slingshot is now being used. This one has as well, and I guess we can get rid of the yellow because we know what it is now. So that's the 4, and sorry, that's green as well. Okay. We have a 1, 2, 4 left in the row. This can't be 4 because they make some of this too high. So that's a 1 or a 2, which makes this one to 8. Nice. That's 8. That's 9. That's 7, which we have 6. That's 1, 2, 2, 1. Puts this 2 in 2. Puts that as 2. Puts that as a 1, and that as a 4, which that sums to 9. That as it should. We can put the 2 here. We can now get rid of our blues. Okay, these are no longer 7s because we have a 7 there. Alright, this is going quite nicely. Okay, any other clues that are done? That's done, that's done, that's done. Those are done. This is not done, it thinks those two are the same digit. I think there's maybe more Sudoku after getting all of this. And the column. No, we just know one has to be on here. Okay. 1. And then a 7, 8, I guess. Yeah, any information about this digit? It's either 4 or it's high. Can't be that high, can it? 1, 2, 3, 4, 5, 6, 7. So it's up to 7. And it's not 1, 2, 3, or 5, just from the column. If it's 1, 2, 3, 4, 5, 6. If it's 6, then that's a 9. Or it can be indexing that, or those two are the same, or those two are the same. Couple options there, all seem plausible. Okay. 2 means that's not a 2, and it's either 4 in the row. Okay, that's just a 3. That's not a 3 anymore, that's a 4 or a 5. But this means these two are the same. And luckily we know straight away those aren't equal. Could be purple though. So keep that in mind. Yellow and purple are still allowed to be the same. Oh, and interestingly, this yellow lines up with this slingshot. So we know it can't be pointing at either any of these cells. Or that one, because it's not 3. Okay, let's just 1, 2, 3, 4, 5, 6, 7. The easiest way is just pencil mark this whole thing. It's not 1, because it'd be pointing there. It's not 2, because that's not yellow. And because there's a 2 in the row. It's not. And it could be 3, if that could be yellow. Can't be 4, because that can't be 4. 5, 1, 2, 3, 4, 5. 5 is good. 6 would make yellow 3, and yellow cannot be 3, because it's these 3. So it's down to 3, 5, or 7. With that cell, and that cell. Can it be 4? Just do neither of these see 4s. So it actually can be. Okay. Okay. This 4, 5 puts this digit 1, 2, 3, 4, 5. This digit as one of those two. I think both work. It'd be funny to think that these could be the same digit. It'd be pretty funny if they would. I'm kind of hoping that happens. Okay. Okay, 1 and 2 in this box are up here. This can't be either 1 or 2, because I'll put this in one of those two spots. Those aren't 1, 2. The 1, 2 in the box are just those two cells. Which leaves 6, 7, and 8 in these 3. 6, 7, 8 puts this 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's not too helpful, is it? Because this can be in any of those 3 cells. Okay. Will be helpful soon, probably. It'd be quite interesting if it puts this cell. Oh, does that work? Yeah, and then this one just indexes back at itself. These are both 7s and those two are the same. That's pretty interesting. Pretty neat setup, that. Okay. Oh, 8, 9. That's not an 8. It's 6 or 7, so it's just down to these two. So I could colour this, but we have multiple colours here that could be the same. And the more I add to that, the more confusing it's going. Okay, now I just do it. And just remember, most of these colours are still allowed to be equal to each other. They're just to notate where certain of these slingshots are going, and we just can't assume that they're different. Just make sure we don't assume these colours are different. Okay. Yeah, this is probably not making it less confusing. This one, let's green that cell because if marks of those two are equal. Yeah, mark pencil mark these as 1 and the 7, 8, 9. This is just a naked triple. 1, 2, 3, 4, 5, 6. Wait. Oh yeah, we know one of those two is a 6. Just wait. You have an 8, 9 pair in the box. That's just 6, 7. Okay, which just makes that a 4. That that's been there a while, and that just makes that an 8, 9 there. Yeah, those aren't disambiguated, but that certainly is, which puts that there. And I mean that can't be blue because that cell goes there, there. And if those are both blue, well, there's two blues in the column, so that's not blue. That is, and that's a 1 or 2. This, let's get rid of red because we don't need that. But what we can mark is that cell goes there. And then we can get rid of that one because that one's now been marked in the grid. This is a 6 because of those are 6 apart. 3, yeah. Okay, pencil mark these because we only got 3 left. 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 5, 6, 7. Okay, and that's not a 3. 4, 6, 9. Okay, that being the same as that is still possible if they're both 9s. And being the same as that. Okay, it's not a 4 though. This isn't 4, which means these two aren't the same. Ah, that's fine. This actually sees quite a lot of digits. Let's just, because these 1, 2, 3 here, and it sees 5 and 6 up, and it sees 4, and it sees 5 and 6. So it's just a high digit. Oh, and it sees 9. Okay, it's just a 7, 8, which gives us a nice pair there. That actually was worth doing. Wasn't sure if it would be. Okay. This is, yeah, yellow is no longer 4. And if we look at this again, we have 1, 2, 3, 4, 5, 7. It's not 4 because yellow sees 4, so we can go with the 7 option. Also, let's just quickly mark that as red because I can see these have to be the same because of the 7, 8 pairs there. Which means if this is 5, it goes here, and yellow is equal to red, but yellow is not equal to red, as we can see down here. So therefore, this is a 3, and that cell is yellow. And surely we have some information about what yellow is by now. But I'm not sure if we... Oh, it's not 2, 3, and 4 from this row. And it's not 5 and 6. Okay, that might be enough to be worth pencil marking it. It's not 2, 3, 4, it's not 5 or 6, and it's not a 1. Okay, from there. So it's just 7, 8, or 9. Yeah, that's low enough to have been worth pencil marking. That clue is done now. That clue is done now. This 3 sees that. That's not a 3, which puts that a 3. Got a lot of 3s. Yeah, we've got a 3 here, and then the bottom two 3s are many options. Oh, we can remove 9 from those pencil marks. And you've got that. This cell. I feel like this is going to be, I mean, this is basically the last slingshot that I haven't looked at yet, so let's look at it. It's, first of all, minimum 6. Maximum 6, sorry. It's not a 4. Okay. I was going to say, move that as one of the options, but that's really not an option. 5 picks those two equal, and that doesn't work because that's not a 4. Then we can get rid of 5. I think that might actually be it. Okay, that was slightly disappointing. Yellows. Can we say anything more about yellow? It's here or here, depending on whether it's 7 or 9, 7 or 8, 9. Okay, this one says either that's 6 or that's 9. 6 or 9. Okay, not seeing anything interesting with that just yet. We have a lot of 4s. There's only 2 spots left for 4 in this box, and 4 down here is in the bottom row, which is not overly helpful. Yeah, that arrow is done. Any unused? That's the only arrow we haven't. The only slingshot we haven't used yet. Sorry, these two are the only slingshots we haven't used yet. And then, yeah, that that is the only. Those are the only clues we haven't actually used yet. Not a lot left, but ones in this. Those two ones see into here. So we've got one down to these spots. Doesn't see anything. Blue is down to over here because the 1, 2 means blue's not there, and these ones are seen from the columns. So any styles that just see a lot of digits, like this can't be 1, 2, 3, or 4, but everything higher than that seems fine. Yes, purple. We can put that as purple because, yeah, I mean just from the column. Then looking at the 8, 9s, that has to be purple. Can I say anything else about purple? Not really. Don't know where it goes in these. Depends on whether it's 8 or 9. So purple is over here. It's not there actually. Oh yeah. Oh no, can purple be red? Can purple be red? I think it can. Like if all of these are equal. Yeah, yeah, that seems fine. Okay. Yeah, but purple isn't there, so purple does only have 2 spots in the row, and then purple's up here. Then more colouring we can do, or is it more Sudoku we can do? 2s? No. We don't have that many of the high digits. It's mostly low digits we have a lot of, but not quite enough. Like 3s, we have most of the 3s, but we can't place the last few of them. We have a lot of 1s, don't we? No, we don't actually. Okay, 1 in this row. I've looked at this before. It's only got 2 options. Because that's obviously by that one. But both of these seem valid. This one's interesting because it forces purple. Yeah. Okay, if this is 6, okay, I was gonna say 6 in a row, but we'll put 6 in a row there anyway, just by the slingshot. Okay, that's a funny deduction. If this is 6, that's 4 because of what we know about this, which means if that's 6, that's 4, that makes that a 9. That solves never a 9. That's probably not helpful, but it's pretty cool. And 5, 9 does not does not force another digit in the same way. Okay, what's the next step here? What can this digit be? It's basically anything that's not 7, 8, or 9, which is the issue, because that's the same for most of these. And that digit goes here, goes there, and then it goes in some other places that are seem fine at first glance. Gets bounced around the grid quite a bit, but I don't see how that breaks, unfortunately. 5 in the box goes there. It's too many options to be nice. Okay, that's nice. If that's a 9. Yeah, if that's a 9, then that's a 9. Sees 9 in those and puts 9 up here. And puts 9 there. Okay, that is interesting. That's very interesting. Because this cell is always purple then. Sorry, always orange. Because if this is a 6, if this is a 6, this is a 4, and that's a 9, and that's a 6. This is a 9, where we can have, I guess we can have 4. Yeah, if this is 9, I guess we can have 4 and a 9 here. Or we can have 5 and a 9 there, which also places, yeah, which also places 9 here just by Sudoku. So that cell is always put orange. This cell is like potentially orange as well. But that being 4 is always valid for the slingshot. We can personalize this as 6, 9, I suppose. Oh, that means it's not 1. Yeah, which means 1 in the row goes here. Nice. Okay. That's another digit. That's nice. Let's color this other. Oh, we have a lot of colors. Let's use light gray. We don't have light gray in the grid yet. This is for the other 8, 9. So it's there, and it's not there, and it's there. Yeah, that's the important bit. Because this digit in this box can't be there, and we know it's not there because then it moves it from up here. So it has to be here, which means that's not 7, which means that is 7, and that's 8, 8, 9, 9, 9, 8. Let's get rid of purple now. Let's get rid of light grey. That doesn't tell us whether that's purple or not, funnily enough. Okay, that feels like quite an important step. Resolve the last arrow, and that's just the slingshots left. 8 in this box goes here. Yellow sees a 9 now, so we can move 9 from there, which gives us a 7, 8 pair, which means we've got 5, 6, 9 as the only digits left in the row. Okay. Nice. 5. Yeah, 5 storm there. I think look at the 8th and 9th. Yeah, 8. Yes, 8 in this box is there. 8 in this box is there. Uh, let's undo that slightly. 8 in this box is not on any of those, and the swap there because of the 7-8 pair. 8 in this box is there. So 8 is red. Yellow is 7. That means that 8. We can get rid of yellow colours now. We can get rid of red now. Okay, so we went down. We've got all our 8th place now. 7s, we can get 5, 7. 1, 2, 3, we can get 6, 7. And now all our 7s are placed as well. Lovely. We've still got this clue unused. I feel like it's only going to use quite late apparently. Oh no, we've used it already actually. We've used it to just prove it being 7, 8, 9. Okay, fair enough then. Well, yeah, all 7s placed, all 8s placed. See if we can do some 9s. We can, because 9 in this box is not there or there. So that's a 9, which means orange is 9. And that being 4, 5 both work. I'm going to colour as green because it doesn't matter whether it's 4 or 5. And we can get rid of our orange colouring. That's not a 9 anymore. Place some more 9s. 9 in this box is not any of those because of those. So 9 goes there. 9 in this box. See those. So 9 goes there. 9 in the centre box. We have those ones. See, colour highlight the right cells. Those cells see all of those. So that's a 9, which makes that a 4 by apply pencil marks. 1 and 2 left in the column. Remove 1 and 2 from here. That's not 3 and 6. These are 3, 6, and 5. This is not a 6 because that would put a 1, 2 here. That's a 3. These are not 3. That's not a 3. That's a 3. This cell goes there. That's a 5 and a 6. 5, 6 makes that another 1, 2 to finish out the column. 5, 6. That's a 4, 5, 6 for the row. That's not a 9. 5 makes that a 4, which we know that already works. That makes 6 and 4 and not 4. And in the column we have a 1 left, which resolves 2, 1, that's a 1, that's a 2, that's a what, that's a 2. This is 1, 5, 6. Those two are the same 5, 6, but let's not worry about that for now. That's 3, that's not 3, that's a 3. We have 4, 5, 6 in the row, which leaves 1 found in the box. That's a 2. 2 sees that and that. So that's a 2. That's a 4. So that's not a 4. That's a 4. That is a 5 and 6. It's not a 5. That's a 6. 5, 6, 5, 6, 5, 6. And that is now a 1. I guess we can. No, let's get rid of the colour. Get rid of the blues. 5, 6, 5, 1, and let's colour this green because those are the same. And put in the 1 to finish the puzzle. Boom! 43 minutes. That was a very nice puzzle. Very nicely done. Some pretty cool interactions with the arrows, and this whole section right at the start was very interesting. Like that. A lot of interesting colouring and some interesting interaction between like where the low digits go and how the math works out with these was very nicely done. The flow of the puzzle was generally quite nice. Second half had a bit more scanning to do than the first half, but still was pretty wasn't too bad. It was quite nice. That was quite nice deduction with this going into here. I think I was missing that one for a while, but yeah, overall pretty nice puzzle. Yeah, enjoyed that one a lot. So thank you for the puzzle. Thank you everyone for watching. Hope you enjoyed the video, and goodbye.